Okay, we're looking today at matrix multiplication. So we've got the number of hours worked in a week and the hourly wages of the company's part-time employees that are shown below. So what they're doing here is they're giving you a word problem kind of as a way of introducing this matrix multiplication so you can kind of see how it works. So what I've got here is, looks like Kay that makes $6 an hour, Dave makes $5 an hour, and then how much time they worked during week 1, week 2, so on and so forth. So if I'm looking at how much money Kay made just in week 1, let's say she worked 20 hours and she makes $6 an hour, so I'd just do 20 times 6, which would give me 120. And then for Dave, we're doing the same thing. Well, Dave makes $5 an hour, and he worked 12 hours. So I'll do 12 times 5, which gets me $60. Okay, then if I want to know the total amount paid to these employees in week 1, all I would do is add those two together. So 120 plus 60 gives me $180. So for that I just did 120 plus 60 to get that 180 right there. Okay, then it says find the amount paid to each employee during week 2 and the total amount for week 2. So Kay again will work 10 hours this week and makes $6 an hour still. So she'd have $60. And Dave only worked 8 hours that week and made $5 an hour still, which would be $40. Then my total, again, is just adding those two together. So total paid out was $100. And you could do the same thing for week 3, multiply 5 and 6, 5 and 9, add it together, and get your totals there. So, sorry, couldn't see that last part. Note the process that you have used to answer these questions is called matrix multiplication. So, finding the amount that was paid to each employee in week 1, what we really did was we took and multiplied row 1 times the first matrix entry. So the row 1, I multiplied the 20 and 12 times column 1 here. So I did 20 times 6, 12 times 5. So we're not going straight down like this and this here. Whatever's here gets flipped on its side and multiplied down. So then we added the products to determine the total amount for week 1. So let's use matrix multiplication to find the indicated totals and complete the matrix that I've got below. So really we've got did the first two, which were 180 and 100. Then for the last one, week 3, I do 6 times 5 plus 9 times 5, so 30 plus 45, which should get me $75. Okay, now we're not adding all those together to find a total because when you're doing something like this, you're getting running totals for the week in a layout that allows you to see it just split up week by week. So that would be our completed matrix here. So noticing a couple things, you had a 3 by 2 and you ended up with a 3 by 1, whereas you had a 2 by 1 here and ended up with a little bit more. So we'll talk about that looking at the next page here. So when we're looking at these and asking, can these matrices be multiplied? We're going to look at the inner two numbers. So what that means is, when I put what my dimensions are for this one, so this one has 2 rows and 1 column, so it's a 2 by 1, and this one has 2 rows and 2 columns, so 2 by 2. And I look at the inner two numbers, which would be the number of columns for the first one and the number of rows for the second one. And that says no, it cannot be multiplied together because those two numbers are not the same. So let's look at what happens if they are the same. So this one has 2 rows and 2 columns. Then we have the next one, 2 rows and 3 columns. So notice it's not that the rows are the same, because here my rows were both 2. That doesn't make a difference for us. What we're really looking at is the columns for the first one, the rows for the second one. So looking at those, yes, they are the same. So what that means is, when I multiply those out, this is what the result is going to look like. It'll look like a 2 by 3. So since the inner numbers match, they can be multiplied. The size we just said would be a 2 by 3, looking at the outside numbers. So let's look at a few examples here. I've got, this one is a 2 rows by 2 columns, and then we have a 2 rows by 3 columns. So those match. That means my answer is going to end up as a 2 by 3. So let's start figuring out how we multiply these together. So as I multiply them, I'm going to always multiply first column by the first row. So that's why we look at, or the first row here by the first column, which is why we look at the columns to make sure they're the same as the rows here, because when we multiply, so I'm going to be doing those times those here. Now, what I'm going to do here is write them out as ordered pairs, because when I do that, it really helps me to keep the multiplication lined up. So on the first one, I've got a 4 and a 2. Then I'm going to multiply that by -1 and -2. Then the answer that I get, I'm going to end up adding together. So I multiply each part. 4 times -1. So we'll write that out for us. 4 times -1. And I'm going to add that to my second part, which is 2 times a -2. That gives me -4 minus 4, which would end up being a -8. Now it's writing down a few more steps than what I would actually write down, but what that does is, since I'm going to have a 2 by 3, that gives me my first number up here in that top column. So -8 goes up there in the top. So then I'm going to take and I'm going to redraw my matrix here for us. So 4 and 2, -1 and 3, multiplying that by -1, -2, 3, 0, 5, and -6. So now that I've multiplied the first part, I'm going to move on and keep using my first row here, but I'm moving on to the second column here. And when I multiply that all out, it's going to go in my second part right there. So I have a 4 and a 2. It's going to be multiplied by a 3 and a 0. So I'm multiplying that out. Again, I do 4 times 3. Then we're going to add that to 2 times 0. Okay, and that just gives us 12 plus 0. So 12 plus 0 just equals 12. So that's going to be my second number there. Okay, I'll draw it out for you one more time. So still using the same 4 by 2 or 2 by 2 times this 2 by 3. For this one, we're multiplying by this last column to give us my number up here. And still using the 4 and the 2. So we have 4 and 2. It's going to be multiplied by 5 and 6. And we can start as we go through this, really shortening it, saying, well, I know 4 times 5 is going to be 20. And, oh, that's a -6. And 2 times -6 gives me a -12. Do 20 minus 12 gets me a +8. So that finishes off the first row of our answers there. Now I keep going. So next thing I'm looking at is going to be my second row on the first one, and I'm going to start the whole process over again. So without writing it out, let's just write out the multiplication we're doing. That times my first row. Then I'm going to do that same thing times the second column, and then times the last column, so 5, -6. Okay, so as I multiply that out, you get -1 times -1 is a +1. 3 times -2 gives me -6, which equals a -5. So I'm going to try and keep writing down those numbers as I get them. So -1 times 3 gives me a -3. 3 times 0 gives me 0. So just a -3. And the last one, -1 times 5 gives me -5, plus 3 times -6, -18, which would give me -23. So, when it's all said and done, and I've worked out all those numbers, I end up with my answer matrix here. It is a 2 by 3. So that is our steps to go through. So a lot of steps, but really just doing some easy addition and multiplication each time. Let's look at the next one. So I've got a 2 row by 3 column and a 2 row by 2 column. So I'll look at the inside there, and what that tells me is can't multiply them. So, get an easy out on that number 4. Yeah, I'll post another video going over a couple more, but that is your basic steps as we multiply matrices.